And then I'll give you some ideas about what will happen, because there is the product side, and this is one example for a product where we have reduced the emission by 30%. This is the FutureCem product that we launched in 2021, and after a slow start now, the market is really taking FutureCem into consideration, and we now are selling into the ready-mix market. Maybe 30-40% of consumption they use the FutureCem product. So, and that will give not only the reduction here, but it will also give our customers a reduction in their calculations. The same technology will apply for other grey products, but also the same principles we'll use in our new white cement products going forward. This is just an example, and later today we'll have our external speaker explaining why CO2 reductions or CO2 footprint in future buildings are important. But if you use in a standard apartment building FutureCem instead of the normal grey cement, you can actually reduce 1,600 tons of CO2 in the building in a lifetime. It's just one example. The biggest contribution will come from the fuels. To get rid of fossil fuels, we have committed that in 2030 we will not use fossil fuels. We will not use coal, we will not use petcoke, we will not use oil. That's our commitment. There are two ways to go. First of all, we will exploit to get as much biomass fuel as possible. In this case, it's what we call biomass waste fuels, because there are different kinds of biomass. You can go and buy wood pellets, but this is not okay, because we are only looking for biomass that is categorized as a waste product. And there are different categorizations in the European system. But what we look at is only biomass waste products, because we don't want to be part of what we can call the greenwashing. So we need to make very sure that we only buy certified biomass waste products. It's a very difficult market, because right now, due to the energy crisis, all kind of sources are looking for other kind of energy types. So this market is attractive, but it's very difficult to get standard biomass waste products. What we will do for sure is that already next year we will start using, first of all, natural gas. And the idea with this is that over the time from 26 to 2030, we will every year gradually increase the use of biogas. And that will, for you, be very important, because then you on the white cement, that will be a fuel that will keep the color in the white cement. So that will be biogas. And Denmark, by the way, is one of the biggest producers of biogas. There's a big, because it's linked to the farming and agriculture industry in Denmark. But that will give a huge reduction, and we already have installed the pipeline for infrastructure. It's just sitting outside the factory. We have purchased the burners, also the gas burners for the kilns. So we will start the first campaigns next year, end of next year, on one of the white kilns. So that will gradually improve emissions on white kilns. And if we did it 100%, we could take away, if all fuels use biogas on white cement, that will give a reduction of, that's 800 kilos, approximately. So white cement would be down to 500 kilo per ton of cement. Today it's 1.3 ton of CO2 per ton of white cement, basically. So it could reduce by 800 kilo by 2030. And then for sure more competitive than outside Europe, unless they use biogas. So that's the plan. And then the last part of the plan is to install carbon capture. It's to get rid of the emission we have from raw materials from the chalk. We need to capture CO2. And therefore the plan is to build a facility, minimum 400,000 tons. Most likely we are looking at a facility of up to 800,000 tons of CO2. This is just a picture, but it's just to show that such kind of facility will have the same size as the plant today, more or less. So when you hear about carbon capture, you believe it's just a small box you have in the corner. It's a big box you have, and the energy consumption is the double per ton of CO2 than you have per ton of cement. So you need enormous amount of green power. It's not available today. You need to build offshore wind turbine facilities of I don't know how many megawatts or gigawatts. And you need green power, because if I just put it in the plug now, it will be based on black power, right? So you have to make sure you can base it on availability, on access to green power, and this is the challenge. And then the challenge, of course, is to find where a place to store it. But this is good in Denmark, because Denmark has, and this is where we are very lucky, because normally we don't have any raw materials except chalk. But exactly, we have the structures to store CO2. So Denmark-Norway region is the perfect structures to store CO2. So that's the good part, is that near shore and offshore storage will be available in Denmark. We are already now working, and we will just go outside and see today that we are working together with different universities on a pilot facility. In the future, we need to capture minimum 1,000 tons per day. This facility captures 1 ton a day. So this is a small facility in front of the kiln, but the idea with this facility is not to show that we can capture 1 ton. We can easily capture 1 ton per day. What we do here is a lot of research about what is the perfect setup for the chemical process. How do you make it energy efficient? So where do we find the balance between capturing and energy consumption in the process? So we're doing a lot of tests. The good part is that emission from cement has a high concentration of CO2 compared to other industries. So that's the good part. The bad part is in cement emission, you also have a little dust. You have some sulfur, and you have some, do you call it noxon? Yeah. And the ammonia process that's used here, they don't like dust, sulfur, and NOx. So this is what we try to, so basically we try to find as many failures as possible to learn. That's the idea with the pilot facility. When it runs, it easily catches 1 ton a day. And we simply have connected the pipe to the big stack. We capture 1 ton per day, and then we put it back to the stack again, because we don't have a process to use the CO2. But it's working, and you'll go and see it. The difference is that CO2 capture, it's a chemical facility we set up. It's not a cement facility. So it's also different skills you need in a society to capture CO2. This is just about when they built the process. It comes like in box containers. It's pre-built, and they put it together. And it's amazing about what kind of attention you get. We have a CO2 emission of 2.1 million tons per day, and of course we get a lot of negative comments on that from public. But when we put up this facility that capture 1 ton a day, we were like the heroes for a week. And because it's really difficult to relate what is 2.2 million tons per day. But if you set up a facility, the attention, the positive attention this gives is enormous, that you actually work on reducing emission and you share it with public. And there was a huge attention, and the number of press releases on this was enormous in Denmark. But in reality, it was about 1 ton per day. I'll go forward here. And then just to share that, are we now very unique in Denmark on the solutions? No, we are not very unique on the solutions or the path that we follow, but we are most likely, as we go on the product, on the green fuels and on the CO2 capture in a parallel stream, we will most likely hit the targets sooner than some of the other competitors. Because when you look into the Global Cement and Concrete Association, they have you can say, some of the same measures, better products, better fuels, and then they also have carbon capture and storage. And this is, it's unavoidable to have, as if you need to reach a 70% target or 50% target, you need to work with carbon capture and storage. And this is just to share that this is recognized across the world that this is a solution that you need. And in Denmark, we still discuss, do we really need carbon capture? Yes. If we need, as a society, to reach 70%, it's needed. It's unavoidable.